Hi, Chris Kuzmal here. Today we're going to be solving integration by substitution by looking at how you create problems of this form rather than trying to figure out how to solve problems of this form. Of course, in doing so, we'll make it easier to solve problems of this form. So if we have the integral of g prime of x times f of g of x dx, that is, say, the derivative of g of x times the composition of f with g of x dx. So we're going to integrate that. If we do the substitution that u equals g of x, then du is g prime of x dx. And so dx is du divided by g prime of x. Okay. That means that then this integral up here transforms. The g prime stays the same. F of g of x becomes f of u because remember, g of x was u. And dx becomes du divided by g prime of x, which means that these g primes cancel, and all we're left with is f of u du, which, if f is integrable, any integrable f will now be a solve. We can solve any problem where we have which involves any integrable f, or if it's easily integrated. And the slide doesn't show, but it's any g at all will work. Well, any differentiable g, which generally speaking, any g is differentiable. So let's start with relatively simply, certainly a simple f and a pretty simple g. Okay, certainly we know the derivative of the sine of x. Hopefully we do. That's going to be the cosine of x. So if we can take the derivative of this guy here, oops, actually I misspeak. If we take the derivative of, if we can integrate this guy here, then we're in good shape, and we expect to be able to take the derivative of this guy here, and we can. So we want to be able to integrate g prime of. So the problem we create is the derivative of this times f of this. Okay, the derivative of g times f of g. Okay, so substituting in cosine of x times the sine of x. The sine of x is f of x of sine of x is just the sine of x because the x is the identity function. Okay, and so the function that the problem you're given is integrate the cosine of x times the sine of x. Well, the substitution that's called for based on this problem setup is to say that u equals the sine of x. And then you turn the crank, and of course dx is du divided by the cosine of x, and so the integral is the cosine of x du, cosine of x times u times du times cosine of x, because this here u is just, remember what f is, f being x, right? Now x is replaced with u. And then, be careful here, sine of x is u. And so I apologize, sine of x is u, and therefore sine of x becomes u, cosine of x remains cosine of x, but then dx is du over cosine of x. The cosines cancel, and we're just integrating u du, which is u squared over 2 plus c, substitute in for u being sine of x, and the answer is 1/2 sine squared x plus a constant. Okay, so lovely. And actually, here's a fun problem. Once we've set this up, you might think, well, let's just make g of x cosine of x. We end up creating what appears to be the identical problem. Everything here is identical, except we've effectively swapped which function we're substituting in for. And the problem setup's difference is only the sign. And so the integral of the sine of x times the cosine of x is 1/2 the sine squared of x. But the integral of the negative sine of x times the cosine of x is 1/2 the cosine squared of x. And that's a mind-blowing result, right? Because it seems like these two things should be the exact same form. There should be just a sign difference between them. And in fact, that is there. If you look at the trigonometric identity of sine squared and cosine squared, then you'll find that in fact they are just a sign difference between them. So there you go. Plus a constant maybe. There's more later.